So now we're going to jump into our chapter 11. And chapter 11, I will say, after chapter 8 and chapter 9 material, chapter 11 is kind of a breeze. We're back down to um, the easier concepts. And so this section 11.1 is going to focus on distance, midpoint formulas, and circles. What are our objectives? Being able to use both the distance and the midpoint formula, and then writing the equation of a circle in standard form, and then working with the general form of the equation of a circle. So learning how to graph circles is definitely going to pop up, as well as finding the radii of circles and their respective center points. First up is our distance formula. And the distance formula is really, I guess I'll just highlight. I had the blue all pasted and ready to go, but it's okay. Distance formula is really just Pythagorean theorem in disguise. We're looking at finding the length of a diagonal, and we're in two dimensions now, x, y coordinate plane. And so we're just looking at it from a point perspective. I'll show it to you just visually down here. What do I mean by that? Let's say we had a right triangle in our first quadrant. And I'm going to be a little bit more specific here. I'm going to label these points. We'll call this point A, point B, and point C. And so opposite our capital letters, which are denoted by our angles, we're going to have our lowercase letters, which are going to be the lengths of the sides. So I can zoom in so you can see it actually a little bit better. So we once again have A, B, C, but this time little a, little b, little c. And then let's also put in our x and y axis so that we can clearly state, okay, well, our x coordinate for C and B is, we'll call this x2. And then for our A, our x coordinate lies at x1. And then for our y coordinates at A and C, we have a little y1. And then at our B, we're going to call this our y2. Okay. So we know Pythagorean theorem. What is Pythagorean theorem? Our two legs, right? Our a squared plus our b squared is equal to our hypotenuse squared. Now let's look at this from a coordinate perspective. We want to find the length of this diagonal, AB. And so how do we go ahead and do that? Well, our a squared, which is this length over here, we want to find how long this is. Let's look at point B in terms of x2, comma, y2, because that's our B coordinate. Our point C is x2, comma, y1. And because this is a right triangle, our x2s are exactly the same. So when we're looking at the distance of this, we just need to find the difference between y2 and y1. Hence, y2 minus y1 in parentheses squared. So we have our A is equal to, and to make it just a line, I'm going to just put B along this side and A here. So let me switch these. We could have also just said by commutative property that we could switch it, but I want you to really understand this. So we have our B is simply equal to y2 minus y1. Okay. Now let's look at our length A, and we're finding this length BC, but notice that it's a horizontal line because of this right angle. Vertical line intersects a horizontal line. And that means we can neglect our y values because our point B is really just x1 comma y1. And so they both share that same y value. And so we just take the difference between our two x's, and that gives us our distance of A. X2 minus x1. So I'm actually going to unhighlight this distance formula and really lean in on, okay, A squared, our A squared, plus our B squared is equal to our C squared. Okay. And so when we look at this A squared plus B squared equals C squared, how do we get C? We take the square root. So C squared, I'll put C squared first. C squared equals A squared plus B squared. Take the square root of both sides, and we get our C, aka our purple, is equal to the square root of our A squared plus our B squared. And now you can clearly see, okay, if our A is x2 minus x1 squared plus our B, which is our y2 minus y1, and then squared, then there we have it. Pythagorean theorem in disguise, just from 2 dimensions, dealing with point, our whole coordinate system. Okay, so now that we know that, now let's apply it to example 1. And we'll be much more efficient here. Our 2 points, we want to find the distance between. So -5, we're going to call that our first x coordinate point. -3, our first y coordinate point. 7 is going to be our second x coordinate point. And 2 is our second y coordinate point. So we get our distance formula. I'll write out the general x2 minus x1 in parentheses squared plus y2 minus y1 in parentheses squared. And now we're just going to substitute in our values. 7 minus -5 plus 2 minus -3. 2 negatives next to each other give you a positive. 7 plus 5 is 12. 2 plus 3 is 5. 12 squared is 144. 5 squared is 25. Add the two together and you get 169. And the square root of 169 is 13. And that's your answer. Let's continue and tackle another example together. This time I won't write the general formula. I'll just jump right into it. x1, y1, x2, y2. -1 minus 10 in parentheses squared plus parentheses 5 minus -4 squared. -11 squared plus 9 squared gives us 121 plus 81, which gives us 202. And we want to ask ourselves, can we simplify this further? And we cannot. So this is in fully simplified radical form. And we're done. Second objective is our midpoint formula. Midpoint, I like to think of the middle point, and then thinking about, okay, if I took 2 exams in my math class, what would be my average exam score? You add the 2 exams up, and what do we divide by? The number of exams there are, which are 2. So you add them up, divide by 2. Same exact concept here. It's just now we're finding the middle point between two different coordinate points that have 2 different x values and 2 different y values. So what do? We take the average of your 2x values, add them up, divide by 2, and then you take the average of your y values, add them up, divide by 2. You got your coordinate, that's your midpoint. So midpoint formula, this is just the notation of it. Okay, it's the middle point of a line segment. So now knowing this, let's apply it to our example 3. We're asked to find the midpoint between P1 and P2. So we're asked to find our M. So M is equal to your average of your 2x values, x1 plus x2 divided by 2. This is our x1, this is our x2. And then our 2y values for your y coordinate point. y1 plus y2 divided by 2. This is my y2. Sorry, that's my y1. And this is my y2. So now let's just plug in. We have -5 plus 3 over 2, comma, 5 plus 1 over 2. Simplify. -5 plus 3 is -2 over 2. 5 plus 1 is 6 over 2. -2 over 2 is just -1. 6 over 2 is 3. So our midpoint is just -1, comma 3. And that's it. Easy enough. All right, let's move on to our objective 3, which is writing equations of circles in standard form. So what is a circle? It's a set of points in the XY plane that are a fixed distance r from a fixed point hk, where r represents our radius and our k or our h comma k represents our center point of the circle. So center point and then radius. Standard form of a circle is just putting it into our in parentheses h x minus h close parentheses squared plus y minus k close parentheses squared is equal to our r squared, right? And if we're looking at x squared plus y squared is equal to some number r squared, then that means our center point is just simply 0, 0 at the origin. All right. So let's do example 4 together now. And so we're asked to write the standard form for the equation of the circle with a radius of 5 and a center point, h comma k, of -3 comma 6, which tells us that our h is -3 and our k is 6. What is our general equation, aka our standard equation of a circle? X minus h in parentheses squared plus y minus k in parentheses squared is equal to r squared. So now we're just plugging in at this point. Our r is just 5. Our h, -3. And then our k is 6. So we end up with x minus -3 in parentheses squared plus y minus 6 in parentheses squared is equal to 5 squared. Can simplify a little bit. 2 negatives next to each other give us a positive. And so we get x plus 3 in parentheses squared plus y minus 6 in parentheses squared is equal to 25. And you can also keep it as 5 squared to really just hone in that our radius is 5 just by looking at our standard form. And we're done. Let's do another example. So we're asked to once again write our standard form of our equation of a circle, but now we're given a different center point. We have 2 comma 4. And then we're given that the circle itself contains the point. So circle contains point -2 comma 1. And so if we look at this visually on a graph, you'll be able to see that we're going to actually have to use these 2 points in order to calculate our radius. And I should be more accurate, right? Our center point is 2 comma 4. So let me just actually plot the center point first and then put the circle around that. That seems about right. And then we have -2 comma 1. I'm going to say is over here about, not drawn to scale. So we're going to use these points in order to calculate our r. How do we do that? We go back to our good old distance formula. So that's our first step. So Distance, aka our r here, is equal to the square root of, I'm going to call this our x1, y1, x2, y2. Doesn't matter which one's our first xy coordinate point and which one's our second. You just need to make sure that they correspond accordingly once you label it. So we have -2 minus 2 in parentheses squared plus our 1 minus 4. And when we simplify this, I'm going to do some shrinking. Right, that's better. We end up getting -4 in parentheses squared plus -3 in parentheses squared. So 16 plus 9, which gives us 25. And the square root of 25 gives us our radius of 5. Okay. Now that we know our radius, we can plug it back in to our standard form of a circle. X minus our h, which is 2, and our k is 4. So x minus 2 in parentheses squared plus y minus 4 in parentheses squared is equal to 5 squared. And that's it. We did it. Graphing a circle. So right now it's almost in standard form, right? Remember our standard form x minus h in parentheses squared plus y minus k in parentheses squared equals r squared. So that last bit, we just have r squared is 16. And so our r is 4. We can write that as 4 in parentheses squared to really see, or just 4 squared, that 4 is our radius. And then our center point, our h comma k, is equal to -3 comma 2. So now that you have all of that, it seems like graphing a circle would be quite scary, but it's actually, I think it's easier than graphing a line. All you have to do is plot your center point. So we have 1, 2, 3, so -3, comma, +2, 1, 2. All right, that's our center point, and we'll label it -3, comma 2, center point. Put H, comma, K. And then we have a radius of 5. So we're just going north, south, east, west, 5 units. 1, 2, 3, 4, 5. And then plotting that point north. Let's do south. 1, 2, 3, 4, 5. Plotting this one south. Right? Let's do east. 1, 2, 3, 4, 5. And then let's do west. 1, 2, 3, 4, 5. Right. And then this is the fun part. We're just gonna create a dashed circle line, which is much easier when you have a pencil because it doesn't work well on the iPad. But on the iPad, what I actually like to do is I will just draw the circle as a dashed circle. So let's see if this works. Might be a little too big, but let me see if I could shrink it. We got it. Yeah, it's good enough. I'll even move these over slightly. And then we're good. Perfect. That's our circle. And then last but not least, we want to write the equation of the circle out. Just like that, right? Let's do another example together. I believe these are actually the same equations, plus 3 minus 2. They are. So this example is asking us to find the intercepts, if any, of the graph of the circle. So we did all this work on this previous example. Let's not waste it. So I'm just gonna copy this over and put it onto this slide. And that way we can very clearly see our intercepts. We have y-intercepts and we have two x-intercepts. We should probably also calculate it technically to make sure that the points are accurate. So I think we'll just end up doing that. Our x-intercept, definition of x-intercept, when our y equals 0. And then definition of our y-intercept when x equals 0. So when we plug that in, we end up getting 3 squared plus y minus 2 squared is equal to 16, which is just y minus 2 squared is equal to 16 minus 9, which is 7. Take the square root of both sides and you get y minus 2 is the square root of 7, which means our y-intercept is going to be square root of 7 plus 2. I'm going to move this down here. Or we can write 2 plus square root of 7. So as a coordinate point, it's going to be 0, comma, 2 plus square root of 7, which probably is really close to 6. Let me calculate it for you guys. Not so close. It's about 4.64. So this graph was just not drawn to scale. Okay. So yeah, this y-intercept is 2 plus square root of 7. There's 0, comma, 2 plus square root of 7. Now let's calculate our x-intercept. We just have to plug in 0 wherever we see y now. So we have x plus 3 in parentheses squared plus negative 2 in parentheses squared is equal to 16. So we get x plus 3 in parentheses squared plus 4 equals 16. I'll zoom in so you can see it more clearly. Bring that 4 over to that right-hand side. And so 16 minus 4 gives you 12. Now we're going to go ahead and take the square root of both sides. And so we get x plus 3 is equal to the square root of 12, which is the same as the square root of 4 times the square root of 3. Subtract 3 from both sides. And the square root of 4 is just 2, so we end up getting 2 square root of 3 minus 3. And we really should put in, um, this is what I actually forgot. When you take the square root, you potentially have the positive and negative version. So it's really a plus or minus 2 square root of 3 minus 3. And the same goes for actually our y-intercept. We have two different values. We have 2 plus or minus square root of 7. So let's make that edit. Plus or minus, plus or minus. Because notice, look, there's another y-intercept down here. So in coordinate form for our x-intercepts, we end up getting, let's do negative 2 square root of 3 minus 3 comma 0 and positive 2 square root of 3 minus 3 comma 0. And there we have it. I edited this so you could really see the two different points separately, and I filled in these two. Right? Again, circle not drawn to scale. I did the best I could. Okay, our fourth objective is working with our general form of the equation of a circle. And so general form is just foiling out your standard form. So x plus 3 in parentheses squared is the same as x squared plus 6x plus 9. And then our y minus 2 in parentheses squared is the same as y squared minus 4y squared plus 4. And so this is known as our standard form, whereas we used this top one, did I say standard form? This is known as our general form. And this top one, which is in standard form, is what we used in both examples 6 and 7. So I'll write standard form versus our general form. And it's crazy because when I was in grade school, I learned it opposite. So I don't know what's going on with these new math textbooks to switch it up on us, but I feel like this should be the standard form and this should be the general. Same with equations, quadratic equations. Our standard form versus our general form. Apparently, our general form is our, uh, oh no, it's not general. It's the difference between standard and vertex form. Our standard form is a in parentheses x minus h, close parentheses squared plus k. But I was taught that that's vertex form. So yeah, I don't know. Modern math. Okay, so let's see. That is everything that we need to know on this slide. Um, this is, maybe we should touch upon this really quickly. So if any equation in the form of x squared plus y squared plus ax plus by plus c equals 0, then we know that it has a graph of a circle or it has no graph at all. So if you're able to graph it, then we're looking at a circle. But if we're not, then we can't even graph it. Okay, so our definition of our general form of the equation of a circle is now formally defined. I'll put it in green, but it's exactly what we had on that previous slide. And what we do is if we're presented with our general form, then we utilize our knowledge of completing the square in order to put it into that standard form, which I'll once again write down here so you guys explicitly really know the difference between the two. Example 8. Let's practice our completing the square. So we want to complete the square to make this a perfect square trinomial, and then write the results as a binomial squared. So all we have to do is find that manipulative constant c that technically we would add to both sides, but because this is an expression, we just have to add it once. So we use our special key, our b over 2 in parentheses squared. Our a value here is 1, right? 1x squared. Our b value here is negative 26. And now we just plug it in. Negative 26 over 2, that just gives us negative 13. And then we want to square that, so we get positive 169. That's what we add in order to get our perfect square trinomial. So now we have it. We have our x squared minus 26x plus 169. That was the first part. Now the second part is we want to write this as a binomial squared, aka we just want to factor it. And we use our special key once again. It's just we use what's inside our parentheses after it's simplified. So that minus 13 is how we can easily just factor this quadratic. X minus 13. And we're done. Our binomial squared. Right? Example 9, this is our last example for this section. And we are asked to show that this equation represents a circle. We want to find the center point and the radius, aka put this into standard form, aka we need to complete the square 2 times. So let's rewrite. We have our x squared. I'm going to pair all of the x's to one side. So maybe I'll color code my x's to be yellow. And then I'm going to pair all of my y's right next to it. And then I'm going to bring all of the numbers and constants to that right-hand side. So aka gonna subtract 7 from both sides, so we get that negative 7. Okay, with the x's, we have our x squared plus 2x. And I'm going to leave a little space. And with the y's, we have our y squared minus 6y. I'm going to leave a little space. That little space is where we're going to add in that manipulative constant. But we're completing the square twice. We're completing it for our x values. So I'll put that completing the square over here. And then we're completing it for our y values. So I'll put that over here. Might be too much, but we'll erase some of the highlight if we finish it up here. Okay, use our special key, our b over 2 in parentheses squared. And so our a for our yellow is 1, our b is 2. Our a for our blue is 1, our b is negative 6. And so our b over 2 in parentheses squared for our blue is negative 6 over 2 in parentheses squared, which is the same as negative 3 in parentheses squared, which is 9. So this 9 is what we're going to add to our blue section, but whatever we add to that left-hand side, we also have to add to that right. Now let's solve our yellow. Our b here is 2. 2 divided by 2 is 1. and 1 squared is 1. So we're adding 1 to our yellow. And again, whatever we add to that left-hand side, we also have to add to our right. Now let's maybe shrink this part over here to have some more space. Okay, that's better. And now we're ready to factor. Our yellow can be factored into, again, let's use our special key. What did we have in parentheses over here? We simplified that to 1. So this yellow is just x plus 1 in parentheses squared plus, and then our blue, when we factor that, what did we have in parentheses there? A minus 3. So this is just y minus 3 in parentheses squared. This is all equal to, what are all of these numbers added up? Well, 9 minus 7 is just 2, plus 1 gives you 3. And there we have it. Our equation is now in our standard form. And so we can easily identify our center point, which is our h comma k, is just equal to negative 1 comma 3. And then our radius, which is our r, is just equal to the square root of 3, since 3 is technically r squared. And we have completed example 9. This is also the last example for this section. So please let me know if you have any questions. I hope that you have a strong understanding of distance formula, midpoint formula, as well as working with circles. And then I will see you guys next time with our section 11.3, which focuses on ellipses. Take care. Bye.